so confident, so solid, so seamless. Oh yeah, that pulls nicely. It does make you feel proud that it's American technology, it's American workers, it's a union shop. It's really great. It's amazing what you can do.
It's such a high-tech product. It's arguably the most complicated consumer product in the market.
Yeah, and it's such an aspirational vehicle. People may dream of Ferraris and McLarens, but that's just dreaming. This is a car you can actually achieve. But compared to everything else that has equal power and speed, cost, it's 2 to 3 times the cost of this car. Jay Leno's Garage, once again being visited by automotive royalty. Now, see, when they say that, most times it involves a car that costs hundreds of thousands, if not millions of dollars. This time it's not about price, but about quality. We're going to take a look inside and outside on the new E-RAY Corvette. And it's pretty unbelievable when you see how this thing is built and put together. I'm proud that it's an American-built car, built in a union shop, built at a pretty good price. We don't have an exact price. In and around $100,000 is what it's going to cost. All-wheel drive, the fastest accelerating Corvette ever produced, at least up to this point, and we have it here first. And when we go through this, you will see in this chassis and all the other pieces just how advanced it is. You know, a lot of times when you build a car a little bit less than what they're building somewhere else, you cut corners. I don't think there's any corners cut in this. The materials, the efficiency of how it's done, it's pretty unbelievable. Now, before we today, Chaz, come on in here, my friend.
Great to see you, Jay.
Good to see you. I'm just stunned looking at this. You know, as I was telling him before, when the C8 first came out and it was priced around $65,000 to $70,000, I thought, no, it's probably going to have, just a standard GM transmission or something. No. The amount of magnesium, aluminum, exotic metals, it's certainly the equal of anything the Europeans are doing at probably a third of the price. So you've got to be real proud of this.
Oh, we're so happy with the way the car has been, everybody's embraced it all around the world. Obviously, we see it here in America, but really globally, we're doing right-hand drive, so we're selling in Australia and UK and Japan. So it's really been embraced around the world, and the reception here has been phenomenal. It's hard to believe it's been 4 years since we revealed it, but we've actually already sold 120,000 C8s. So you think about the entire 7th generation life cycle, that was about 190,000. Probably sometime next year, we'll pass the total number of Corvettes built in the last generation car.
Well, and there's certainly a good reason why people are buying it. You know, I love the fact that you're not afraid to take a chance, you know. So many other manufacturers have to stick to tradition. You know, I remember the Fit Corvette owners, the taillights aren't round, it's not a Corvette, oh my God. You know, whereas this is a totally new concept. All-wheel drive all the time. Yep. Do you call it all-wheel or four-wheel? What do you call it?
It's all-wheel drive.
All-wheel drive. Okay. Hybrid car, and you can run on electric for what? 4 or 5 miles, something like that.
Yes,
okay.
It's a what we call neighborhood exit or stealth mode.
Right.
It's a mode you can put it in if you want to just keep it pure electric.
Right.
So you think about, like a lot of us who work on the car, when you start a Corvette, it's an event. You know, it makes a fair amount of noise. And sometimes you're getting up in the morning or you don't want to wake up your neighbors.
Right.
You can use it to exit, get out of your neighborhood, and then start it someplace else, wake up somebody else's neighbors instead of your own. Or if you're sneaking in late at night and you want everybody to know what time you're coming in, you can.
Well, I just love the fact that you have Corvettes for whatever your situation is. You've got the Z06, which is the out-and-out performance car, a little bit lighter. You've got this one, the fastest accelerating. You've got touring car. I mean, it's almost like it is a separate brand, I guess, almost a standalone. So take us through here, what we have here. This is the chassis for the new C8 E-RAY. Up here, this is our electric drive here. Battery is in the center tunnel, is that correct?
That's correct.
Okay.
And when we first started thinking about a mid-engine architecture, one of the advantages, even though we needed a structural backbone, because all Corvettes are convertible, so they don't have a roof. So you have to do big body structure elements down the center of the car to make it very stiff. So we knew we had to have that tunnel, but there's no drive shaft, there's no exhaust that goes through it like on prior generations. So we were thinking, what are we going to do with that? How can we use that? In the back of our mind, we'd had customers who said, why don't you guys do all-wheel drive. And so we looked actually at a mechanical all-wheel drive where you'd run a shaft up, forward the engine to the front axle, versus electric. And at that time, GM was starting to go heavy into electric. We had a lot of electric technology. And so when we looked at the mechanical versus electrical alternatives, just on the pure basis of what it does for the car, the electric won out. The big advantage of electric, of course, is you can get energy back. Every time you hit the brakes or even lift the throttle, you use regen on the front axle, and you fill that battery up instead of when you hit brakes, it all goes to heat, and you never get that energy back.
Now, is the regen adjustable or is it set?
It's set. There's different modes. So typically, it tries to maintain a certain battery state of charge, so you always have that all-wheel drive capability. With different modes, it changes the calibration a little bit, so it might target a higher state of charge, or even be more aggressive and target a lower state of charge, such that you're, doing hero lap on a track, for example. So I'm going to use everything the battery's got to make the car as fast as possible. This battery is so small. It's interesting. The battery is 1.9 kilowatt hours, so that's about as much energy as in 1 cup of fuel.
Wow.
So it's a very small amount of energy. You say, okay, what good is that? What good it is that the energy in 1 cup of fuel is about equivalent to this car at top speed. So you think about a braking event at top speed, you can get the equivalent of that amount of energy back into the battery. So in a gas car, you burn a cup of fuel, it's gone forever.
Right.
In this car, you get a lot of it back.
And the amount of energy in a cup of fuel, I remember I did this once. They took a cup. How big an explosion would it be? A cup of fuel, and he needed just a huge amount of battery. I mean, just batteries all in the room, just to equal this in terms of how much actual power is in a cup. Gasoline is a great
it's
fuel.
An amazing substance.
It's an amazing fuel, and to find something better is really hard, but we're getting there, and we're getting closer.
Right, and this car really takes advantage of the best of both worlds, and that was our idea. Some people, as you know, are scared off on electrification. Oh, it's going to be the end of sports cars, it's going to be the end of fun cars. If you look at this car and you drive this car, as you will do, you'll find it's nothing but positive. You don't lose anything.
Right.
You get more power, you get all-wheel drive, very assured handling in all situations. You still keep the front trunk, you get better fuel economy because of the regen. You get everything better and nothing worse. And you'll see the way it sounds, you still have the beautiful sound of the V8, but when you really get on it and you can hear that engine really pumping out 160 horsepower, they blend together in this great crescendo as the car just rockets ahead.
Well, this is the fastest accelerating Corvette you can get, even more than this Z06, correct?
Yeah, even though it's got a lower power to weight ratio than the Z06.
Right.
In terms of 0 to 60 and quarter mile, this car gets off the line, as you'll see. It just bangs off the line.
Right.
The good thing about electric motors is infinite torque.
Right.
All the torque immediately at 0 RPM. So right off the line, this car just jumps out ahead of it.
And the other thing I like is the fact that I remember saying to you, oh man, what happens when you tweak this? It's got to be impossible to fix. But everything here is components.
Yeah, so when we started, actually in the 7th generation, we started doing all aluminum underbody structures. We had to think about what's the repair procedures. And so the way we join the car, a lot of it isn't welded anymore. A lot of it's glued together and screwed together. So with fixtures, you can actually put it back together. You don't need specialized welding equipment.
Right.
And then we build pieces of the car, sub-assemblies, in our production factory, so they're all dimensionally accurate. So a body shop can plug those and put them in the car.
And also the fact that even with all these components, you still have a trunk. I've got an NSX, which is a nice car, but you can't carry anything. I mean, you have maybe a toothbrush or something. Or, I can't carry, if I have a passenger, I can't even bring the valise I use because it doesn't fit. The person would have to hold it. Well, you still got it's still got that Corvette usability, which I find.
Yep, that's why we say it's a Swiss Army knife. It still does everything well. Just like Stingray and a Z06, you can take off the top. It goes in the back. You still have your whole front trunk, which is the size of a airline rollerboard bag, and we find people absolutely love the two trunks. So whichever direction you approach the car, there's a space for you to set something. The shapes are different, so like grocery bags fit great in the front. They stand up, they don't fall over.
And you said something which I didn't realize, that every Corvette is a convertible. Because I keep thinking in the old days you'd build, you're really, the strongest structure would be the fixed roof, and then when they cut the roof off, there's more bracing underneath. Right. But you start with the strongest possible convertible chassis you can build.
Right.
Which is interesting. I didn't realize that till you just said it.
Yeah, actually, it's been that way since the 5th generation car.
Yeah.
We started, even though we did do some fixture, we started with a convertible, and that's why you've seen the backbone tunnel construction since then. And it's not just a tunnel that you see, it's closed on 4 sides.
Right.
And that makes a very stiff structure for torsion. That bottom plate is very, very important. It's carbon fiber on the other Z06s. We actually use the battery pack as that reinforcement on this car.
And the other thing I find amazing is the exotic metals. How are you guys able to have this when other manufacturers charge so much? Is it just efficiency of, is it volume? Is it the power of GM and suppliers?
There's some of that, the economies of scale of being
Right.
part of General Motors. We have really good relationships with a lot of our suppliers. But really, since 1953, this car has been a mosaic of materials. It's been alternative materials. Don't just make everything out of steel, which is the way it was, and actually still is in
Right.
the auto industry. But really, over 70 years of evolution, we've found the right mix of materials between what you see here, mostly aluminum, but you don't see here is all the composites. You see some of them back here,
Right.
but we bond all those composites on. So it's a mix of the best material in every place, whether it's aluminum, in some places steel, whether it's magnesium, whether it's carbon fiber, whether it's glass reinforced composites. Every part is designed specifically for what it has to do.
But it's not there because it's cheaper. It's there because it's the best part. You just be able to do it less expensively. My favorite thing with my McLaren, I always tell people when I cracked it, I can either get another splitter for the front, or I can get a Corvette. The same price. Here's a piece of plastic. I can either have this or this, and it's just it just makes me laugh every time I think of it because. How is that possible?
How often do you have to buy a new splitter for your McLaren?
It's happened. With California roads, please. All right, take us some more of what we have.
So we're really proud of this drive unit. I mentioned you still have the frunk. It's a magnesium case. It's actually all aluminum fasteners. It's extremely compact.
And no connection with the rear.
That's
Once again, to reiterate, this is not a drive shaft, all-wheel drive. You get the torque. No, this is a whole separate drive unit right up there.
Yes, it's completely modular, front and rear. I think we're the only car in the world that does that. Almost every other hybrid packages motors between the engine and the trans.
Right.
So the motors actually drive, coaxially. This is a completely separate drive unit. So the big challenge for us was how do you make this feel to the driver like one propulsion system? So that was very, very challenging. We started from the beginning. We didn't want to lose what's great about a mid-engine car, so the weight distribution, that sense of low polar moment of inertia that the car turns in immediately when you steer. So we didn't want to load up the front axle with a bunch of mass. So everything about this is extremely light, extremely compact, totally bespoke to us. It's actually, that whole drive unit and the battery that we'll talk about is built in Brownstown, Michigan. So it's about 40 miles from where we designed the car and where the proving grounds test the car. And we do everything. There's no shared parts with any other car, whether it's in GM or outside. Even the motor windings are done there. We do those in-house.
So this is bespoke to Corvette.
Completely bespoke.
There's no parts bin thing here.
Yep, weighs about 80 pounds for that whole drive unit.
And the really cool thing, if you're looking at this, if you live in Australia or England or Japan, or you can't get a left-hand driver, it's not legal, this literally, take it and you move it right over here. Because as you can see with this component, you don't have a steering column and you don't have all the things in the way. So it's easy to build a world car, isn't it?
Yeah, so mid-engine car lets the front be very symmetrical. You don't have an engine and all the other stuff conflicting, having to move parts and plumbing around. So we can translate the driver over to the other side. We translate the brakes and things over, but since you don't have anything in the way, the engine, it actually translates relatively easily.
And how many radiators? I'm trying to count radiators here. This is pretty amazing. How many in here?
I don't know what the total is. We could walk around and count it, but it'll take a while. I don't know if you have enough time.
But a lot.
There's a lot. So when we did the Z06, and this wide body. We stuffed it full of heat exchangers to cool that, track monster car. We actually have as much cooling on this car and more radiators because there's more to cool.
Right.
That drive unit, that has to be cooled. The power electronics in the battery, which we'll talk about, has to be cooled. The battery cells themselves also have to be cooled. And this car's completely track capable, which is not typical of any electrified cars. So we try to keep the temperatures down as much as possible, plus all the normal things. Air conditioning.
And what are we cooling? Are we using a waterless coolant, or is this not water, is it?
It's a coolant mix.
Just a coolant mix. It's
Yes.
nothing exotic.
It depends on which cooling cert you're talking about.
Right.
Like we actually use a chiller for the cells themselves. So we actually use AC refrigerant and plumb a little bit of that under certain conditions, like track conditions, where the energies go flying into the battery, flying out of the battery. That brings temperatures up. So we take a little bit of the AC refrigerant and run it through there to keep it from getting too hot.
Oh, very good. And again, just the way it's all bolted together, I find that really fascinating, because if you do tweak it, and a lot of people do, it's not crazy. A friend of mine had a Porsche Carrera GT, and he bumped the curb right here. Slid in it. Oh, well, that's not too bad. The dealer said, well, $128,000. Just what? I mean, and that's not to fix it. That's just, he was like, oh my God. It was like crazy. And the fact that this can be repaired is, I like the fact that you're just thinking ahead for idiots like me who might damage it,
Well, I hope not.
No,
Especially not
no.
today.
Fans, radios. Okay, what else we got here?
So there's some pretty trick stuff on here. You see all the radiators out front. You can see a little teeny one that isn't on the Z06 right in here. That actually does that front drive unit. We actually take the condenser, that's for the air conditioning, and we actually split it 2/3, 1/3, and we just use the bottom to do some of the power electronics cooling.
Now, a car like this, you come with I think it's probably a C-Tech battery charger, correct? Is that who does it for Corvette? I think they do. I'm not sure.
Oh, to do a trickle charger?
Yeah.
A 12-volt battery?
A car like this, you always want to keep on a trickle charger.
If you're going to store it for any length of time, you want to keep the 12-volt battery. And that's actually another thing I didn't mention. This car has a lithium-ion 12-volt battery, too. So in addition to the lithium-ion propulsion battery, the 12-volt, the normal lead-acid batteries that you think about, that we use on the other Corvette models, we actually went to lithium-ion, which some manufacturers offer that as an option to save a little bit of weight. It's tremendously expensive, but it's standard on this car.
It is, yeah.
And,
they last a long time.
They do last a long time, and they can produce a lot of amps. The engine cranks like this.
Yeah, my McLaren is a 12, so that's 11 years old, 12 years old. It's still the battery's fine. I put a voltage. It's fine.
Yeah.
It's amazing. So lithium-ion is really the way to go.
Yeah, and that's what the res is. A lot of people have expressed concerns. Well, how long is that battery going to last? Is it going to last the life of the car? It will. We're going to have a 100,000-mile warranty on it, 8 years. And what it'll happen is it might get slightly less effective after that time, but it's not like it's going to suddenly short out and die and you have to replace it.
Right. I mean, you might lose 2% after 5 or 6 years, something like that.
It trails off, just like anything else, like your phone, anything that has powered by batteries.
Let's move to the back here. Very nice. Now, here's a word I'm not familiar with. Pultruded, is that how to say it?
Pultruded.
Pultruded carbon fiber. Now, what does that mean? I think I know. What's that mean?
So that part that we're looking at here is a carbon fiber bumper beam, so that protects the back of the car from low-speed impacts. That's actually standard on all C8 generations cars.
Right.
It's the first curved pultruded bumper beam in the industry. The reason why we're using it, we've used carbon fiber in various places around the car, and it all depends on where you want to save the weight. So the reason why you see it at the very back end of the car is that on a mid-engine car, the most important weight you can save is on the very back.
Right.
You don't want too much weight in the back. And so when you actually make this is actually replacing an aluminum part. So an already light part, but a pultruded part,
even lighter.
Even lighter. And since it takes weight off the back, it lightens the weight load on the rear wheels. It actually adds a little weight to the back. And the reason why it's called pultrude, a lot of people are familiar with extrusions, like aluminum extrusions. We use a lot of them on this car. you push the metal through a die to create that shape. In this case, you actually use the strength of the carbon fiber and you pull it through a die to create the shape that it is.
Yeah, if you want a good example, I drive a car from the 50s with the Continental wheel kit on the back. I hate those things, because you go to the far end of the car, then you bring it out even more, and then you hang a tire on it. If you ever drove in like a 50s Packard or even a Cadillac, no, it's, the rear end is just swinging out.
That's exactly what we're trying to avoid.
Yeah,
right
exactly. Okay. And we have a lot of low density SMC. What does that mean?
Sheet molded compound.
Okay.
So that's one of the forms of composites that we use around the car. Corvettes since 1953 have been using fiberglass composite.
No sheet.
No sheet, yes.
Oh, wow.
But now we have sheet molded SMC, and there's various configurations of it. Some are just glass based, some are glass and carbon based. You can see they're black. These are painted, but if you look on a real car, you'll see that it looks like a black, because you can actually see the carbon. It's extremely lightweight, extremely strong. It's actually all bonded to the aluminum structure. And you were talking about repairability. That's one way we can repair a car. If you get dinged on the corner back here, the metal won't bend. This stuff will crush, and you can glue a new piece back on.
Right. Okay. And the brakes, like in most cars, the steel brakes are standard, then you pay extra for the upgrade. But these are the upgraded brakes, right?
Yes, these are the biggest ceramic brakes we've ever done, and they're standard on this car. Ceramic brakes are typically a $8,000 to $10,000 option over a performance steel brake.
Right.
And you might think, well, why'd you go so far on this? Ceramic brakes are great for really everything. Unsprung mass is good. They take the weight out of the whole car. It's a very expensive way to take weight out of the car, but the braking performance is really important, especially in electrified vehicles. And you see some of the very high-end EVs that use ceramic brakes, and there's reasons for that. First, the very high-end EVs are very high performance, and so you need a lot of braking capability. And one of the ways you get braking capability is brake cooling. And so the more the brakes can operate at high temperature, the less cooling you need. And the reason that's important on an EV is because brake cooling is drag. You're taking air that would normally flow over and past the car, and you have to turn it and direct it towards brake parts, and they bang, it hits that brake parts, and then it diffuses. And so you're creating drag by doing that. So if you can do less of that and have higher performance brakes, you'll start to see that on a lot of EVs, and that's part of the reason we use it here.
The other thing I find fascinating, because first thing a lot of people do with the Corvette, they buy the aftermarket exhaust system because it's louder, but this is essentially, these are straight pipes basically, aren't they?
Yes, well, it's a valved exhaust system. Right. Braking capability is brake cooling. And so the more the brakes can operate at high temperature, the less cooling you need. And the reason that's important on an EV is because brake cooling is drag. You're taking air that would normally flow over and past the car, and you have to turn it and direct it towards brake parts, and they bang, it hits that brake parts, and then it diffuses. And so you're creating drag by doing that. So if you can do less of that and have higher performance brakes, you'll start to see that on a lot of EVs, and that's part of the reason we use it here.
The other thing I find fascinating, because first thing a lot of people do with the Corvette, they buy the aftermarket exhaust system because it's louder, but this is essentially, these are straight pipes basically, aren't they?
Yes, well, it's a valved exhaust system,
right.
So there's legal requirements for sound and so forth that we have to meet all around the world. And so we have an active exhaust system, have had for a long time, where we use electrically actuated valves that reroute exhaust in different paths. So when you're really on it, so you're asking for maximum performance,
right.
Those valves flip open, and then you bypass all the attenuation parts of the exhaust, and you effectively have headers coming out of the engine and straight pipes out the back.
Yeah, that's a good looking header actually.
It doesn't look like a typical exhaust manifold.
No, it doesn't. It almost looks like some ass. This is the one you want to buy, this aftermarket. Well, that's what's kind of fun. There's really nothing you can do to this to make it better, faster, leaner.
We put a lot of work into getting it where it is. Now, there are laws and regulations that we have to meet that some people in the aftermarket don't, so there's a little bit of opportunity there. But if you look all around the car, you'll see we've tried to maximize everything. Like, one of the great things about a mid-engine is that we can do effectively headers on the car.
Right.
When we had the engine in the front, you had the rails, the crash rails right next to it, and so you had to do heavy cast iron pieces that you had to tuck down into the tunnel. Now we have the space to come straight out, do a header through the catalyst, through the exhaust exhaust straight out the back.
And then you roasted your feet too, and the footwell.
It was pretty warm.
Yeah.
Yes. Now all that heat is behind you. If you look at even the air filter,
Right.
you only see half of it here, but it's a giant performance air filter. So this engine breathes a lot, as does the Z06. And so a lot of times people would I just put in a low restriction air filter. We already have this giant one that is really low restriction.
Right.
You could take the thing out and it would hardly help it at all.
Right. I'm guessing we probably can't drive this one. No, as much fun as that would be.
Well, we engineers have certainly talked about it, and it has not happened yet.
But why don't we take this for a ride?
Absolutely. Let's do it.
Boy, this is great. Boy, it feels like it's billet. It's solid.
It's the same structure we designed.
Right.
The structure originally, not just for convertible, but also, actually, the Z06 is kind of the toughest case because it's got the stiffest springs. So yeah, this car, the chassis is tuned.
So now, is it the Z06?
Z06 is the most expensive. That engine is, it's a race motor.
Right.
So it uses parts from Carrillo. Carrillo out here.
Right.
That makes our pistons and some other stuff too.
Well, that's got to keep them pretty busy, huh?
Oh yeah. Yeah, we're building almost 1,000 Z06s a month now. I know I'm constantly getting talked to about, I can't get my Z06. Why aren't you building any? Well, we're building as many Z06s as we've ever built before.
Yeah.
And just can't keep
And how
up
many
with it.
Corvettes a year do you sell now?
It depends on model year. This year, this 2023 model, it's a longer model year because we're changing over in the fall. It will be, we think, the highest volume Corvette model year ever.
Wow.
70 years, 53,000 units.
Oh, that's great, isn't it?
Yeah, so that's a long model year. We could probably build 40 something in a calendar year.
Now, what do you drive home every day?
This
The
E-RAY. And I just bought a Stingray personally for my own use.
I know a guy that gets you a deal.
So yeah, I didn't get a very good deal. You can do better.
I know. I remember David Brown had asked it Martin, and he sold it to his friend, and his friend said, no, I want it for your price. And he charged him another $1,000 because he said he lost money on every car. The guy was like, no, we're friends. I want it for what you get it for. All right, this is what I have to pay for.
You insist.
It's $1,000 more. This is my favorite story.
Now you can hear the motor kick in.
Yeah. Well, it just feels planted. I do like two-wheel drive. I like stepping out a little bit.
Yeah. Which this is overwhelmingly rear-wheel drive.
Right.
Almost 500 horsepower on the back axle, 160 on the front. And that was about the right proportion, we thought, given the weight distribution of the car. Because when you're accelerating on here, the car's haunching back. You're actually putting more than 60% of the weight on the back. You're lifting the front. So there's only so much you can do as far as tractive.
But the fact that it's the fastest accelerating Corvette, even more so than the Z06, which has more horsepower,
And lighter weight.
yeah, is it because it's just the torque? It's a torque.
It's a torque off the line.
Yeah.
If you watch the cars in a drag race, this car just leaps out in front of the Z06.
Right.
And the Z06 tries to reel it in. Doesn't quite get there before the quarter mile, but then
Right.
shortly after that, it just
Right,
blows
yeah,
by. And on a track, there's no comparison.
Right.
A big speed track anyway. On a tight track, a short track, this car holds its own really, really well too, as far as tractive.
But the fact that it's the fastest accelerating Corvette, even more so than the Z06, which has more horsepower,
And lighter weight.
yeah, is it because it's just the torque? It's a torque.
It's a torque off the line.
Yeah,
If you watch the cars in a drag race, this car just leaps out.
You decide which suits their needs. Do you have a specific type of customer for an E-RAY that's different than the?
Yeah, that's an interesting question. We've had this business challenge for a long time. Corvette history. We bring out kind of the base model, and
Right.
then each model up, we go higher in performance. And people who want the best one are willing to spend more. They want something more premium. We forced them into pure performance, meaning more track capability.
Right.
And so on the prior generation's cars, people who wanted the best Corvette, they'd end up driving a ZR1, and they're driving on racing slicks practically,
Right,
cup
yeah.
tires.
Right.
And so we've always wanted it. We're torn on how do we develop, where do we position this car. We always want to keep it a little daily utility. You've got to be able to drive it to the track's not true. But at the same time, we're competing with track monsters from other manufacturers, and there's a big trade-off there. What this model lets us do is we're going to keep this car the great all-around car and let the Z06 be that track scalpel,
Right.
purpose-built for the person who really is going to drive it on the track, and that's the main thing they care about. So that's why we call that. That's like a road scalpel. This is a Swiss Army knife. It does everything well. You're not going to get stuck in the
I mean, it's an interesting change because in the old days, look, don't confuse the issue. Just build a Corvette and people buy that. You know, the idea that you have so many variations of the same car, that would not have been a good business model 30 or 40 years ago, correct?
Yeah, and if you look prospectively at it, why would you do all these variants?
Right.
But you develop your way, just like the 911. How many variants does the 911
Exactly,
have?
yeah.
And it's because customers use the cars in a different way, and they have individual tastes. Everybody wants something unique, but you can go too far, because if you do too much complexity, then you can't offer it at a good price.
Right.
You don't get volume pricing on stuff. So, yeah, we're trying to get more customization and better targeting for like track versus non-track people.
Right.
And we think this car and the Z06, even though they kind of look the same, they share a lot of parts, they're tuned very differently. And we've seen no drop-off in Z06 orders.
Yeah.
Since you've introduced this car. Some people will sit on their wallet and say, maybe that car would be better than me. It's surprising. The people who are passionate about getting a Z06, they're still passionate. Because that, it's a unique car.
And this is electric power steering?
Yes, it is.
Yeah.
Yeah.
Even that has gotten so good. I remember when electric first came out, it was like, people didn't really like it. But now
Right.
you can't tell it's better than hydraulic.
And there's still people who do lousy electric power steering.
Yeah.
But the best cars are doing it pretty decently now.
And the most horsepower you get from the front is a 168?
160.
160.
160. Very sophisticated means of telling the coefficient of friction between the tire and the road continuously. So the amount of power you get either positively or negatively is based on the amount of friction you have at the tire patch.
I see I have an electric power switch. So when I put my foot in it, we'll see. Okay, I can go to the whole 160.
Yeah, you almost got there briefly,
Yeah.
just momentarily. And that's one thing about an electric motor is you can change the field strength in the electric motor so quickly, it's instant.
Yeah.
So it's not like this engine that has this huge amount of inertia and it doesn't change quite as quickly. You have to wait for the air and fuel to. It's still pretty quick, but compared to electric motor, it's no comparison.
It's fascinating because, every manufacturer has like boutique engineers, a group of men and women that just work on this car. And I imagine within Corvette now you have the E-guys, and that's what they do. And then you have the other Corvette. And so is there one guy that kind of can do all of this, or is that you, I guess, pretty much?
Well, there's quite a few of us who worry about the whole car. But yeah, there's people migrate to Corvette. Once they get to Corvette, they tend to stay there.
Right.
They have a performance passion, and so they find nirvana.
I mean, you have traveling Corvette guys that go to dealerships,
We have service folks, field service folks who go to dealerships. When we bring out a new model, we do dealer training. So we bring people, we bring salespeople to Spring Mountain where we do our driver training.
I thought this was pretty silent behind me. I heard the engine start to whine.
But yeah, you asked about the whole electrification was new to us, and I was telling the story in the garage about what's the best way to do all-wheel drive? Is it electric or mechanical? A lot of people hear something about the E-RAY and they think, somebody must have put a gun to their head and said, you got to do some kind of electrification. That's what's hot. That's what's new. Actually, we started this car before the whole move to heading to 100% EV. So this car was on the books actually before. This predates GM's Ultium system. And so it was really in the infancy of getting EVs on the road when we started it. So we went actually to the people who are doing the Bolt and the Volt batteries. And we said, we're doing a mid-engine car. We got space. We can do a battery. We can do a front drive axle. And so we want to use that to capture energy and give power and performance back to the car. And so we started talking to him about it, and everything we asked him was different than what the other cars needed. Like, we didn't really care about range. It's not about using it as an EV. It's not a plug-in. It's all about quick transfer of energy in and out.
And within our lifetimes, a battery the size of your cell phone will go in there one day. You know what I mean? I mean, to replace it.
Oh, in our lifetimes, I'm not so sure.
Well, McLaren has a replacement battery for the P1, which is like maybe not a little more than half the size of the original battery with more power.
Yeah.
I mean, it moves so.
It is.
It's moving so
moving
quickly.
Fast. Yeah, you were asking about the heat exchangers. The cooling on this car is so complex. With all the different heat exchangers, they all have to coordinate based on how the car is being driven, what kind of environment it's in.
Right.
But we did test this car on the track. It's pretty bulletproof, like the Z06 and Stingray have been. In fact, I was just at Spring Mountain a couple weeks ago, driving Z06s out there, and it's 110 degrees.
Right.
Just roasting hot. And the best place to be was in the seat of the Corvette.
Right.
Hammering on the track, and the cold air is just blasting you. It's pretty impressive. And
Yeah, I mean, the first time I got in the C8 and went around the corner, oh my God, now I see what they're talking about. Thank you.
Yeah. A few complaints we had you can't see the engine.
Right.
So we're fixing that for 24.
Oh, you are?
Yes, we're going to put a glass panel under the tonneau. So people want to go to the show and show off their engine, especially for Z06
Right.
people who want to show off that motor. You can open the tonneau, and there'll be a glass window in there that you can see that.
Oh, that's great. I'm one of those people.
You're one of those people.
I want to see it. Yeah, I want to see it.
It's there, trust us.
And this harkens back to the mid-'60s.
It's all that cockpit stuff. We were talking about that for right-hand drive. So most people who do right-hand drive, this comes straight across.
Right.
There's none of this. It's just flat.
Okay.
And so you can just take the wheel over and plug it in over here. We actually have to tool up all these parts that are aimed towards you. Everything you see is flipped over.
Like I got my 63 split window there. And the radio is upside down sideways. Ooh, that was so cool. I mean, the radio just turned sideways. I don't know why as a kid I thought that was just the greatest, most exotic thing you could possibly imagine. That much horse, you think it'd be 903 or something. It pulls
All that torque.
Yeah,
it's
all
really
that
sweet.
torque.
Small block torque plus EV torque makes it's a beautiful friendship.
Horsepower sells car, torque wins races, right?
Wins hearts too. Because you didn't produce peak horsepower during that run, but it felt strong.
And you have launch control, obviously, with the...
Got launch control. We should do a slap watt so you can feel how it jumps off the line. I don't know if we can do that at just from dead still. You don't have to do launch control, no drag strip start or anything. Just take your foot off the brake and slap the throttle and feel how it jumps off the line.
That's what we'll do up here at this light. Oh yeah, that pulls nicely. Wow, that's amazing. As much as I enjoy wheel spin and smoke, it's wasting time. Let's get you there right now.
Yeah, you've seen some of the videos put out. You can drift this car if you want.
Yeah.
It'll do it.
Well, thanks for coming out to do this. We really appreciate it. And it does, I know it's corny, but it does make you feel proud that it's American technology, it's American workers, it's a union shop. It's really great. It's amazing what you can do when you put your mind to it. It's really, everybody's an engineer now. That's what I love. Everybody in almost all the automotive companies in America are engineers. I mean, you got marketing people, obviously you have to have that kind of stuff, but just the fact that everybody's intimately involved with every aspect of the car.
Yeah.
It's really exciting.
It's such a high-tech product. It's arguably the most complicated consumer product in the market.
Yeah.
With all the regulations all around the world and all the the things you're dealing with, just a piece of complicated machinery, all the safety stuff, emissions, everything is just so complicated. So you really kind of have to be an engineer to understand it. And we and our whole team in Michigan, where we designed the car and where we build it in Kentucky, we're so proud to be able to put together a car that's competitive with anything.
That's
anything
right.
from anywhere.
And it's such an aspirational vehicle. It's a one thing. People may dream of Ferraris and McLarens, but that's just dreaming. This is a car you can actually attain. It's a car you can actually, if you work hard,
Right.
And you pay. It's certainly not an inexpensive car, but compared to everything else that has equal power and speed, cost, it's 2 to 3 times the cost of this car.
And like you said, it's not just the cost to get in it, it's the cost to maintain it.
Right.
Repair it if something happens. You go to your local Chevy store if you need something. So
Right.
It's a very different experience than the exotics that at least I dreamed of, and you have one in your garage, the Countach.
Oh, yeah.
The people dreamed of as a kid, that whole exotic. You think of all the great things, but you don't think about any of the rest of the experience that comes with that.
Hilarious. Yeah. Should be very proud. Thanks for bringing this.
Thanks.
I appreciate it, my friend.
Thanks for having
taking
me,
the time. And anytime we can show off American expertise and technology to the rest of the world, it makes me feel proud. It's great. This is a space race, except it's on the ground, And what you build in here are space shuttles.
Well, we think of them as 2-passenger private jets for the road. I mean, that's what it is.
That's really what it is. That's really what. The first time, I don't know how many people watching say, "I'll get a chance to drive a C8," but the first time you do, the first time you turn that wheel, you go, "Oh, that's what everybody's talking about." That really defined what mid-engine cars were like. I think to most people, somebody put the Corvette in the middle and what difference does it make? I mean, I thought my C7 was the pinnacle in handling it. It was fantastic.
Yeah.
And then I got this one. Oh my God! It just turned on a dime. And the fact that with less horsepower, the first base C8 Corvette was more powerful than the most powerful C7. I mean, it was faster.
Yeah.
I mean, that was an amazing feat.
And that was all intentional. In our original presentations to Bob Lutz about why we should go mid-engine, it had nothing to do with what people think of. Oh, it's exotic, it's cool.
Right.
It was all very quantitative things like you're talking about. Steering response, acceleration, power to the ground, acceleration out of a corner on a track. It was all the things that pushed race cars into being mid-engine, at least in the upper classes.
Right.
So whether you could get that without any downsides was a question. But the other part of it is that you get that steering response, that turn in, that joy of driving, and actually the car rides better than the front engine cars, which is something we were surprised at. And because it did, we're able to use stiffer springs, still ride better even with stiffer springs, and that only enhances the handling.
And it's pultruded.
We got pultruded on here.
Yeah, good. Anytime
Who
you
can brag
use the
about
word
that?
Pultruded, it's fine with me.